Today we're going to start talking about simplifying rational expressions, so we need to recall special case domains and ranges. Those special cases involve radicals and fractional expressions. So last section we took a look at factoring, and it's no surprise that factoring doesn't just magically go away. It's going to play a role in simplifying rational expressions as well, which is basically a fancy way to say a fraction of a variable expression, and there are some rational expressions that we should be familiar with at this time. So on problem 1, we just need to find the domain of each of the rational expressions. So I look at A and I see that I've got 3x squared minus x plus 5. I'm going to ask myself, does this involve a fraction with an x in the denominator? And does it have a square root? If the answer is no to both of those questions, then my domain is all reals. So looking at this, doesn't have a fraction with an x in the denominator, doesn't have a square root, so my domain should be all reals, which can be represented with that weird R thing, which means the set of all real numbers. Or you can say, okay, I've got from negative infinity to positive infinity. Remembering that negative infinity just means that, hey, I'm going all the way to the left, and positive infinity means that I'm going all the way to the right. And since I'm going from all the way to the left to all the way to the right, that's everything in between as well. Alright, on B, I've got 5x minus 6 all underneath that square root. Alright, this time it does involve a square root, so I've got to remember, okay, when do square roots have real numbers underneath? Well, I start counting backwards. I know the square root of 4 is 2, the square root of 1 is 1, and then I'm like, okay, the square root of 0 is usually the one that people forget. The square root of 0 is 0. Keep going back, I get the square root of negative 1. Remembering back from algebra 2, if we have a negative underneath the square root, we get what's called an imaginary number. That's actually 1i. And since I start getting imaginary numbers, I really don't care about those at this time. They're not part of my domain. So I want to know, when can I get my first real number, which would be 0 underneath that square root? Well, in order to find that out, I need to know what underneath the square root is going to give me 0. So how I'm going to find that is I'm literally going to take that 5x minus 6, and I'm going to say, okay, it has to be bigger than or equal to 0. Okay, so then I solve for x. I get 5x is greater than or equal to 6. Divide both sides by 5. X has to be greater than or equal to 6/5. Alright, putting that in set builder notation from way back in the day, I can just put those weird little curly brackets with an X with that little bar thing, and then I get the other little curly bracket, so that reads the set of all x's such that x is greater than or equal to 6/5. Close my set. And I'm done. Or I can say, okay, I start at 6/5 because that's the smallest number x can be. And it can be anything bigger than that. X can be bigger than that 6/5. So going everything bigger than that, well, that's going to go all the way to the right on my number line, which is represented by infinity. Okay, so as we might have noticed over on problem A, infinity always gets a parenthesis because that infinity is never included, because I can always think of one more number beyond the last one that I just mentioned. However, the 6/5, it has an or equal to bar. So because it's got that or equal to bar, that means that 6/5 is included. That is a real number. So how I denote this with what's called interval notation is I actually put a bracket around that said number. So it's going to look like a staple on the end. And with that, I'm done. So again, this is set builder, and this is interval notation. All right. On C, I need to find the domain of each rational expression. So I've got x over 2x minus 3. So I ask myself, okay, does it involve a fraction? Does it involve a square root? Yes, it does. So with fractions, I'm like, okay, what's my special case on fractions? Well, with fractions, I can't divide by 0. If I divide by 0, brain goes boom, calculator gives us an error. It's a bad day in math class. So I want to know, when could this denominator possibly equal 0? Alright, so to find that out, I'm literally going to take that 2x minus 3 and be like, okay, when do you equal 0? Because that's a bad time. Alright, but I also know that this should not equal 0 because it's in the denominator. So how I denote that is I literally just put that little slash through that equal sign to say, hey, I don't want this to equal 0, okay? And then I solve like an algebra 1 problem, so I get 2x is not equal to 3, x is not equal to 3/2. So putting that in set builder notation isn't too bad. As long as I'm good this far, I just put that little bar and that x in front of it with the curly bracket. Again, that reads the set of all x's such that x does not equal 3/2. All right, not too bad. So what this tells me is x can equal everything except this 3/2, right? So it can equal everything before 3/2 and everything after 3/2. So what's going to happen is I can start with everything that comes before negative 3/2. So on my number line, I've got negative 3 or positive 3/2. And I've got everything that comes before 3/2. So that will be represented by negative infinity going that way. So I read my number lines from left to right. So I start with negative infinity. I'm coming in from the left. And then all of a sudden I hit this 3/2, which would be an open circle if I'm actually going back to number lines. Okay, so I can't have 3/2. That's an exception to the rule. And then I can plug in everything after 3/2. All right, so anything after 3/2 and beyond. Buzz Lightyear. All right, and how I say that these two ideas are joined is a union. All right, so a couple things you want to notice. The infinity symbols will always get a parenthesis. And this time, even though I actually have a real number sitting in here, I didn't actually use brackets. I used parentheses. Parentheses indicate that those numbers are not actually included. Okay, so it is everything up until those numbers, but not including those numbers. So I can plug in even 1.52 and it's okay. But 1.5 is a no-go.